Welcome to the Explainer. You know, every single time you send an email, stream a video, or just browse a web page, you're using this invisible architecture that connects the entire world. Today, we're going to build that thing from scratch. We're starting with just a single cable, and we're going to build all the way up to the global internet itself.
So here's the game plan. We're going to start super simple, just one connection. Then we'll look at the different blueprints for building bigger networks. And from there, we'll just keep scaling up from your office to your city and, yep, all the way to the entire planet.
Okay, so if we're going to understand how these massive global networks actually work, we have to start small. I mean as small as it gets. Just one single link connecting two devices.
At its absolute, most basic core, this is all a network is. Seriously, it's just a connection that lets two things talk to each other. Think about plugging your computer directly into your printer with a USB cable. That's it. You've just made a network. It's just a pathway for data to get from point A to point B.
Right away, this brings us to our very first big decision. Are you making a point-to-point connection? That's like having a private, dedicated phone line just for two people. Or are you making a multi-point connection? That's more like an old-school party line, where three or more people have to share the same line and take turns talking. So the moment you go beyond just two devices, things get complicated, and they get complicated fast. You can't just wing it. You need a plan. You need an architectural blueprint. And in the world of networking, we call that blueprint a topology.
You should think of a topology like a floor plan, but for your data. It's not just about what's connected, it's about how it's all connected. It's the physical shape, the actual layout of the network, and that shape determines exactly how information is going to flow.
Okay, so our first blueprint is called the bus topology. I want you to picture a single main road. Every computer is like a house on that road. Now, when one house wants to send a message, it basically just shouts it out onto the street, and every single other house hears it, even if the message wasn't for them. It's simple for sure, but it can get pretty noisy.
So what's the trade-off here? Well, the bus is cheap. It's basically just one long cable. But because everyone is sharing that one lane, you get data traffic jams and all sorts of interference. And honestly, if there's a break somewhere in that main road, trying to find the exact spot to fix it, it can be a total nightmare. Now let's talk about the design that's by far the most common one used today, the star topology. So instead of one main street, I want you to picture a central town square. That's our hub or our switch. Every single device gets its own private road that connects directly to that central point. This is almost certainly how your home and office networks are set up.
All right, next up we have the ring. And yeah, it's exactly what it sounds like. All the devices are connected in a circle, a continuous loop. Data just travels around this loop always in one direction, kind of like traffic on a roundabout. And to keep things from getting chaotic, it uses a neat little method called token passing, where a device has to wait for a special signal, the token, before it's allowed to send any data.
And while that one-way traffic flow is really orderly and reliable, it's got one critical glaring weakness. If just one device in that ring fails, the entire circle is broken. It's exactly like a single broken link in a chain, and it brings the whole network to a grinding halt.
This brings us to the most resilient, most robust design of them all, the mesh. Okay, so forget single roads or neat little circles. In a full mesh network, every single device is connected directly to every other device. It creates this incredible web with dozens of possible paths for data to travel.
With a mesh network, if one connection fails, who cares? It's no big deal. The data just instantly finds another route. This gives you amazing reliability and security. But, and it's a big but, it comes with a huge downside. It is incredibly expensive and super complex to install all those extra cables and connections. So we've got our blueprints down: bus, star, ring, and mesh. Now we can actually start building some real networks of different sizes. Let's start with the ones that are physically closest to us.
So the absolute smallest scale is a personal area network, or a PAN. This is basically the network that exists inside your own personal bubble. You know when your smartphone connects to your wireless headphones using Bluetooth? Or when your laptop syncs up with your tablet? Yep, that's a PAN. You're probably using one right now.
Now, when we scale up just a little bit, we get a local area network, or LAN. This is the network that connects all the devices in your home or in a single office building. And this is where those topologies we just talked about really come to life. Most modern LANs use that star topology because, hey, if your printer goes offline, you definitely don't want it to take down your computer too, right?
Okay, but what happens when you need to connect multiple buildings, like a bunch of offices scattered across different parts of a city? A LAN just isn't big enough for a job like that.
That's where the Metropolitan Area Network, or MAN, comes into play. You can think of a MAN as this high-speed backbone that links all those separate little LANs together across a whole city. So a bank connecting all of its branches, or a university connecting all of its different campuses, that's a MAN in action.
All right, we've connected our desks, we've connected our cities. Now it's time for the final leap. Let's connect the entire planet. A wide area network, or WAN, is the biggest type of network there is. It completely shatters the boundaries of a single city to connect us across states, across countries, and even across whole continents. This is the big league tech that uses those massive undersea fiber optic cables and satellite links to tie the entire world together.
And the core trade-off becomes crystal clear when you put them side by side. LANs are all about giving you super high speeds and really tight security, but in a small, private space. WANs have to sacrifice a little bit of that speed and control to pull off their incredible goal, connecting all of us over absolutely vast distances.
And this is the ultimate punchline. The Internet. The very thing you are using to watch this explainer right now is the most famous, the most complex, and the most widespread example of a wide area network that has ever existed. It's a global web of interconnected networks.
And there you have it. What a journey, right? We started with the simplest possible idea, a single cable connecting two machines. And we've walked through all the blueprints, all the different scales, all the way to the globe-spanning architecture that basically defines our modern world.
So all of this leaves us with one final, pretty big thought to chew on. We went from connecting two devices to connecting billions and billions of people. As our world gets even more connected, with things like smart cities and the Internet of Things, it makes you wonder, what new blueprints, what new types of networks are we going to have to invent next?